So hello everyone, welcome back to Algo Daily. In this particular video, we are discussing LeetCode weekly contest 436, problem number A. And in this problem, we have to given a n cross n square matrix of integer grid, and we have to return the matrix such that these are two conditions. We have to given a bottom left triangle and include the middle diagonals are sorted in non-increasing order, and the diagonals in the top right triangle are sorted in non-decreasing order. And this is our example test cases. And now let's look at their example test cases. Then we have to look their coding implementation part. So in this problem, we have to give an n cross n square matrix, and this square matrix we have to given a two condition we have to performing here. And we need to sort its diagonals, and the specific condition we have to given, and the bottom left triangle with their including their middle diagonals are sorted in non increasing order, and the top right triangle sorted in non decreasing order. And now understand the sorting conditions. Like first we have their bottom left triangle includes their middle diagonals, and the first one is it includes the diagonals starting from their indices like 0 to n minus 1, and the column index, here the column index is 0, and the same for another one, like top right triangle, and this is sorted in non decreasing order, so it means 1 to n minus 1, and here row index is 0, and the number along with these diagonals should be sorted in non decreasing order. So basically non decreasing order is like smallest to largest, and this is non increasing order. Non increasing order means the largest to smallest. And I hope you understand uh, these two conditions like 0 to n minus 1 and 1 to n minus 1, and this non decreasing and non increasing order. And now our goal is to we have to ensure that every diagonals maintain the specific order, and we must extract each diagonals, sort it in the required order, then we have to put it into our matrix. Okay, so now let's look at their example test cases so that you can understand how actually we have to work on their grid positions. And here first example we have their 173, this is our row, this is row, and this is row. And now these are our diagonals, and now we need to sort them a bottom left triangle and the top right triangle. And our first step is we have their 186. Okay, 1 8 and 6. This 1 8 and 6, we have this 186, and we have to sort them into a decreasing order, sorry, descending order, and the descending order is 8 6 and 1. And this non-increasing order we have to calculate here. And basically what we have to get 8 6 and 1. And now our first step, and then our matrix is our grid, you can say our grid is 8 6 and here 1, and the 7 and 3, and 9 2, and here is 4 and 5, and 8 7 3 9 6 2, and 5 4 5 1. And this is our 0 comma 0. And the second iteration we have there 1 comma 0, and this 1 comma 0 we have there this position, and this position we have, sorry, not this position we have there 9 comma 5, and here 9 comma 5 we have to sort. Okay, and sort in uh, descending order, and the descending order we have already sorted here. And so what we have to get, and the same grid at their second iteration we have to get here. And now the third iteration and the third diagonal we have to take care of 2 comma 0, and this 2 comma 0 we have there 4, like here 2 comma 0, here only 4 is present, and so the same value, same grid we have to get here. And now in next iteration we have to sort them at top right corner. Okay, top right triangle, because we have to sort uh, here already, and now we have to sort this one, and here we have to sort 7 comma 2, and this 7 comma 2 is 0 comma 1 index, 0 comma 1, and this 7 comma 2 we have to sort in ascending order. So our grade is 8, like 1 second, 894, and this is 651, and this is 7, and this is 2, and this is 3, and now this is our updated grade. And then the fifth iteration now at this position, and this position we have no need of sorting. So this is our final output, like this is our final output after performing all operations, like 894 and 265 and 371. Here we have to get the same. And now in second example we have to given a 0 1 and 1 2, and now we have to iterate all the diagonals. And the first we have there 0 comma 0, and this is our main diagonal, and here we have 0 comma 0 comma 2, and now 0 comma 2 we have to sort them into descending order. So now what we have to get, we have to get 2 1, and here 1 and 0. And now what we have, this one and this one, but this one we like no need of sorting, so that's why we have to remain same, and here also remain same. So the answer is 2110. And the last example we have there's only one element is present, 0 comma 1, and this 0 comma 1 we do not, sorry, 0 comma 0 basically, and this 0 comma 0 we do not any sorting, and then we have to return the same grade. Okay, so now I hope you understand how we have to work with their diagonals and their positions, and how we calculate all the values. And now let's look at their constraint. The constraint is basically we have their grid dot length, and grid I dot length is equal to n. It means this is n cross n matrix, and each row has exactly n column, and you do not need to handle the cases when where a row and column are different. So this is already given here, this is n cross n is already same, like if 3 column and 3 row already present here. And then the second constraint, 1 less than is equal to n less than is equal to 10. It means the size of the matrix is 10 cross 10 into 10, and since n is small, the maximum 10 an approach of, like you can follow O of n cube, and this O of n cube complexity would be still work efficiently, but uh, each diagonals we have to separately iterate, like n log n solution we have to iterate for sort, like we have to sort them, like if we have to reach their diagonals, like we have reach at this diagonal, but we have to sort in like which order we have to given here, like increasing, decreasing, and so on. So these are our cases. And now in last constraint we have their matrix range value is minus 10 to the power 5 and to 10 to the power 5. It means we have their range of this matrix is minus to plus, like minus 10 to the power 5 to plus 10 to the power 5. And now since the values are large, we cannot use counting sort efficiently, and however we have to use a sort function, and this sort function we have to find their integer values, and we have to calculate their values efficiently. And now let's look at their coding implementation part, how actually we have to work on their diagonals and how we can sort each diagonals. Okay, and now first we have to get the size of their matrix. Here we have to get their size of their matrix, and then we have to follow with iterate with their each row, and this is row. And now we have to sort bottom left triangle and include the main diagonals in the non-increasing order, like here non-increasing order. And after non-increasing order, we have to start with their diagonals with row index, here row index, and this j is our column index. And then we have to store with their diagonals, here we have to store with their diagonals, and then we have their store the indices of their diagonals. Here this pair is store the indices of each diagonals. Okay, and then we have to traverse with their diagonals of this condition of I less than n and j less than n, and then we have to check with their values, and we have to store the current diagonals element at our vector of int a, and then this pair we have to store its coordinates, and then we have to move their next diagonals element, and then we have to sort in non-increasing order. It means non-increasing order means descending order, and then we have to sort them, and then we have the condition of we have to put sorted elements back into our matrix, and this is our approach of new matrix. Like when we have to sort, then we have to store into another matrix. Okay, and now this is for top right triangle. This top right triangle, we have their column, and now we have to sort them into a column, and starting from their diagonals from first row. Okay, this first row we have to start with their diagonals of I is equal to 0 and j is equal to 3. It means I is our row and this j is our column index. Okay, and then we have to perform same operation here, and then here we have to sort only in ascending order. We cannot use a greater int. This greater int means we have to reverse the order. Okay, and then we have to achieve their descending order. Here we have only sort them, and we have to achieve their ascending order of top right triangle. And after this we have to put all the elements back into our matrix, and then we have to return their sorted matrix. Okay, and the time complexity of this code is we have to iterate over n starting points, like n starting point, and for each diagonals we have to extract o of n element, and after sort we have their o of n log n solution, n log n, like o of n log n complexity of sorting algorithm, and then we have to put into our a matrix is taking o of n time, and the total time complexity of this code is o of n log n into n, and this is our time complexity. And the space complexity of this code is like this is basically for this time complexity is basically for the bottom left corner, bottom left, and the same for their top right. Okay, top right, and the total time complexity is o of n log n into n, and the overall complexity is here o of n log n into n, and the total time complexity is o of n square log n. Okay, and the space complexity of this code is we have to use an extra vector, and we have to create a pair and for each diagonals. So the worst case sorting an entire diagonals of their size is the space complexity is O of n, and but since we do not use extra space apart from its O of n, so the space complexity is O of n, and the constraint we have to also given here is like n is small, like n is less than is equal to 1000. So it approach is actually work on their, like we have to find their descending order, then ascending order. So I hope you understand the logic and the implementation part. So basically we have to iterate with this condition, and then this sorting condition we have to take care, like we have to here greater int, but here not greater int, because this is our ascending order and this is our descending order. So thank you everyone, thank you so much.